Hello, my name's Nigel Bowden. I'd like to welcome you to episode 7 of the Wi-Fi for Beginners podcast. This is a series of podcasts discussing the fundamentals of wireless LAN networking. In each episode, we'll take a look at a different aspect of Wi-Fi to build your understanding and knowledge of wireless LAN networks. Each episode will be accompanied by a set of slides describing the topics covered in each episode. Although you won't need to review the slides as you're listening to the audio presentation, they are useful for review later on to have a look at some of the topics we discuss in a little more detail. All recordings and supporting material can be found at our website, which is wififorbeginners.com. Just a few words about the aims of the podcast series. It's a series of audio presentations which I'm trying to present in a fairly easy to consume format. Something you can hopefully listen to on your commute or maybe while you're down at the gym or out jogging. The series is mainly aimed at people who are potentially already IT professionals or maybe students who already have a reasonable level of IT and specifically networking knowledge. I've got to assume a certain level of knowledge during the presentations that I give. Unfortunately, I can't present all of the fundamentals of networking to you, so I've got to assume that you know a little bit about the OSI 7-layer model, a little bit about Ethernet switching, routing, IP addressing, local area networks, and also I'll be assuming as we move through the series that you've listened to some of the previous episodes that I've presented, because each episode does build on previous episodes. And also you need to be aware that we're talking about wireless LAN networking in a commercial or professional environment. We're not talking about home Wi-Fi networks here. A little bit more about me. My name is Nigel Bowden, as I've already said. I'm based in the UK, been in the IT industry for over 30 years, and I'm specialising in wireless LAN networking at the moment. I've got some industry certifications, including the CWNP Certified Wireless Network Expert. I'm CWNE number 135. I've got some Cisco certifications, including CCNP routing and switching, CCNP wireless, and I've got a number of other vendor-specific certifications. My day-to-day role tends to be wireless LAN design, consultancy, deployment of wireless LANs, and I'm also fairly active on social media. You can find me on Twitter. My Twitter handle is @WiFiNigel, and also you can find me over on my blog, which is at wifinigel.com. We're actually into module 3 of the series, and in module 3 we're going to be taking a look at wireless access points. In module 1 we took a high level view of the various components of wireless LAN network. In module 2 we took a look at basic RF theory concepts, and now in module 3 we're taking a look at wireless access points. These are one of the key components that you're going to get very familiar with when you're looking at wireless LAN networks. So the subject areas that we're going to be looking at when we're looking at wireless access points is what is an access point. We'll be looking at what does an access point actually look like. We're looking at access point functions, access point components, access point installation techniques and considerations, how we might configure an access point and some of the configuration parameters we need to be thinking about, and also we'll be looking at some of the IEEE standards which the wireless access points may support. Back in module 1 we described a reference model that we were going to use for reference purposes throughout the series, and just want to recap on that very briefly now so we understand where wireless access points actually fit into our network. If you remember, we talked about a traditional core, distribution and edge layered wired network. So I think we're all fairly familiar hopefully with our high-speed core switches, which are doing a layer 2 switching, our distribution switches which are doing our layer 3 switching, and then out at the edge we've got a number of edge switches which connect directly to user devices. And we talked about the concept of an extended edge, where we're actually connecting our wireless access points into the edge switch ports, so we can extend the edge of our network even further via RF links using a wireless access point, so we can communicate with wireless clients that are moving around our facility. So what actually is an access point? Generally I say in these podcasts that you don't really need to review the slides as you listen to the podcast. In this case it may be quite useful if you did have them to hand. There are quite a few instances where it might be quite nice to actually look at the images that I've posted in the slides. Don't worry too much if you can't see the slides as you're listening to this, but it's certainly worth going and have a look at the slides after you've listened to the presentation at some stage. At the moment I've moved on to slide number 7, and I've actually shown a number of wireless access points, and they're very typical of the size, shape and coloration that you might see. You tend to see wireless access points that are maybe circular, you get some that are square shapes, and you get some that have got antennas protruding out of them. They come in all sorts of shapes and sizes, and so if you get to have a look at slide 7, that'll be quite useful to give you an idea of what a typical access point might look like. So when we're considering access points, also known as APs, I'll start to use the term AP more and more just to cut down on having to say the phrase access point. So when I say AP, access point is what I'm talking about. So what is the primary job of an AP in a wireless LAN network? Well, the primary job is to convert radio frequency signals that are carrying data to and from our wireless clients. So that's things like our laptops, our iPads, iPhones, all the rest of it, all these different clients. And the access point converts the radio frequency signals into data that can flow out through its Ethernet port onto the wired network. That's its primary job. And the access point actually acts as a bridge between the data from clients, which is coming in over the RF link, and the Ethernet wired network. It actually converts between 802.11 frames on the wireless side of the connection and converts those into 802.3 Ethernet frames out on the Ethernet wired port of the access point. It's worth considering that both of these are layer 2 protocols, so 802.11 is only concerned with layer 1 and layer 2 of the OSI stack, in the same way that 802.3 frames are only concerned with layers up to layer 2. Protocols of layer 3 and above are totally unaware of the data link method which is being used down at layer 2. And obviously when the AP converts the data into an Ethernet frame to place it onto the wired network, it's actually placing it onto the edge of the wired network. Just think back to our core distribution and edge model. We're actually putting the data onto the edge of the wired network. Conceptually, it's worth thinking about an access point in two halves. We've already sort of intimated at this. We've got the wireless RF side of it, where we've got our radio, our antennas, and we've also got the wired side of things, which is our Ethernet port, which connects into the edge of our wired network. And as we briefly discussed in our RF theory module, quite often a wireless access point will have more than one radio. Generally, most enterprise level access points tend to have two radios. They tend to have one for the 2.4 GHz band and one for the 5 GHz band. Enterprise level access points will generally have multiple antennas. They may have dedicated antennas for the 2.4 GHz band and a set of antennas dedicated to the 5 GHz band, but more and more these days we are seeing dual function antennas which can support both the 2.4 and 5 GHz bands. AP antennas come in two flavours. We've got internal antennas and we've got external antennas. With internal antennas, you can't generally see them. They're hidden under the cover of the AP, but they are still there, usually mounted directly on the circuit board, and there will be multiple antennas in there. With external antennas, they are generally either mounted on the exterior chassis of the access point, or they may be connected via coaxial cables to an external antenna assembly. It really does depend on what the application and the requirements are for the RF propagation of the particular environment where the AP is being installed. As the RF coverage provided by an access point is limited, it doesn't fill an entire building. They will cover a limited range, maybe a room or a corridor, so we generally have to have a number of them installed throughout a facility, each one providing pools of coverage, as we talked about before. Imagine pools of light that you get from a lamp suspended from the ceiling. So we've got pools of coverage around a facility, and they're generally suspended from ceilings or walls or other mounting and fixing points. We generally want them fairly high up though, so we can get pretty good RF coverage around the area where we're trying to provide wireless LAN connectivity. This is one of those instances where you may actually want to look at the slides. On slide number 10, I've actually provided some more pictures of some access points, and I've put a little tape measure next to the access point's in the image so you can get an idea of the size of them. And as I say, the access points tend to be white in colour. They've sometimes got grills on the front or the side, maybe got a few flashing lights on there. They tend to be about 7 to 8 inches square or 7 to 8 inches in diameter. And to the untrained eye, they may just look like rather large smoke detectors. On slide 11, I've actually flipped all of the APs over onto their front so you can see the rear of them. And this is something which can be quite interesting from an installation perspective. Many access points, or certainly enterprise grade access points, if you flip them over and look on the back, they will have some sort of mounting points for a mounting bracket. It's very common to mount access points onto suspended ceiling rails, so very often you'll have some sort of plastic fixing points to fix directly to the ceiling grids, or maybe fixed to a bracket assembly to fix to ceiling rails, or maybe some sort of wall mounted bracket. Another thing they tend to have in common as well, they will always have at least one Ethernet port. As I said previously, one of the purposes of the wireless access point is to connect into our wired edge network, so we're going to need at least one Ethernet port. And more these days, as we're seeing higher and higher speed access points, we're actually starting to see versions of access point where we have maybe two Ethernet access ports which can be used as a resilient pair or maybe trunked together. One other thing you tend to find on the back of wireless access points as well is some sort of console port. Generally it'll be a serial connection of some sort, and these are generally used for debugging and diagnostic purposes. They can be used as well for basic configuration purposes, but more and more these days the main configuration for an access point tends to come from the controller that it's associated with, or maybe the cloud service that it's talking to. So again, if you've got access to the slide deck, it's worth having a quick look at slide number 12, and what I've tried to do there is outline the functions of a wireless access point. The diagram shows on the far left hand side we've got our wireless clients. We've got things like smartphones and laptops which are making a wireless connection to the antennas of the access points, and on the access point there we're showing at least two antennas. Each of those antennas talks into some radio circuitry which is responsible for receiving and transmitting frames to and from our clients. Beyond the RF circuitry, we've got the usual components you'd expect in a device which does so much processing. We've got some sort of processor, CPU, we've got some sort of memory, and we'll have various ASICs to provide a whole host of functions within the access points. And then beyond that, we've got the other side of our access point, if you remember that RF Ethernet split that I talked about. So then on the wired side, we've got some sort of Ethernet network interface card which is going to connect into our LAN switch. So just to summarise, the core function, if you like, of a wireless access point is to convert the modulated RF signals that go to and from our wireless clients into Ethernet data frames. So effectively we're talking about a layer 2 translation. We're converting from 802.11 frames to 802.3 frames, or vice versa, depending on the direction of the data flow, whether it's going to a client or from a client. And what this effectively allows us to do is to have a wireless client device and for its data to still be handled by the wired network, even though it's using a wireless link. So we're effectively extending the edge of the wired network out via wireless connections, as we've already discussed a couple of times previously. And I mentioned there modulated RF signals, and again back in our RF theory module we talked a little bit about modulation. Just going to recap it very briefly again. So with modulation we have a basic radio frequency signal, and we will change some characteristic of that radio signal to represent the data, the binary data that we want to transmit back and forth. So an RF signal on its own, just a pure RF signal at a particular frequency, doesn't actually carry or convey any sort of data. It's just an AC signal, an alternating current signal. But if we actually change some characteristic of the AC signal in response to the incoming binary data stream, so we get a binary stream of ones and zeros, we can change some characteristic of the RF signal and use that to convey the binary data when it's received at the far end of an RF link. An example we've used before, but I'll recap it again. we've got a concept of frequency shift keying, whereby we have a central frequency which the radio frequency link is operating on, and by actually shifting the frequency of the signal up slightly we may represent a binary 1, and we shift the frequency down slightly to represent a binary 0, and by shifting the frequency up and down in response to the incoming binary 1s and 0s from the data stream, and to transmit binary data across a radio frequency link. Okay, then, in the final topic for this particular podcast, we're going to take a little bit of a deep dive into antennas. We've already spoken a little bit about them already, but it's a very important component within a wireless access point, and all access points must have at least one antenna. And in any RF system, you need at least one radiating element, the antenna, to transmit and to receive signals, and that's the purpose of the antenna in the access point, is to receive and transmit signals to and from our wireless clients. It's also worth noting that the same antenna is used to transmit and to receive. We don't have a separate antenna for transmitting and a separate antenna for receiving. The same antenna is dual purpose, used for both. And generally APs will have more than one radio. We tend to have one radio for the 2.4 GHz band and one radio for the 5 GHz band, and we must have at least one antenna per radio. To be honest, modern access points which are using modern 802.11 standards will require multiple antennas per radio, because we have the concept of multiple streams being sent and received at the same times, and we need an antenna per stream. And we generally find that you will have 2, 3, maybe even 4 antennas per radio on modern access points. So if you think about a 2-band radio which has got 4 antennas, you could end up with 8 for a 2 radio AP, and that may get extended even further in the future as wireless standards get extended and built upon. Don't forget, we have always got antennas in an access point, even if you can't see them, even if they're hidden away under the hood, under the cover of the access point. They'll be mounted inside on the main circuit board within the AP chassis. And if we've got external antennas, you can see them. They're usually mounted directly onto the external chassis of the access point, or they'll be connected via coaxial cables to an external antenna assembly mounted somewhere near to the AP. One of the big questions in wireless LAN design is which type of antennas should we use. Should we use the internal antennas that come built into an access point, or should we buy access points that we can attach external antennas to? And the decision process is determined by the RF performance that we require for the particular environment that we're deploying the wireless LAN into. In addition to that as well, we've also got aesthetic considerations. Sometimes, particularly in office areas, there may be objections to actually using external antennas which aren't quite so easy on the eye as an access point which has got internal antennas which are out of sight. In terms of antenna types, there are broadly 2 groups of antennas we can use. There are omnidirectional antennas, which tend to broadcast in all directions at once, and we've got directional antennas which tend to focus the RF signal in one particular direction. You may also hear the term semi-directional antennas as well, but for the moment we'll just stick at omnidirectional and directional antennas for ease of explanation. And we've talked about internal and external antennas with regard to access points, and generally what you will find is that internal antennas which are inside an access point tend to be fairly omnidirectional in nature. So if you hang one on the ceiling, you can generally think of the RF signal radiating in all directions, very much akin to our light bulb analogy that we've used a few times now. External antennas which are connected to an access point may be omnidirectional, or they may be directional. It really does depend on what is appropriate for the particular venue that we're deploying the wireless LAN into, and as we've said, they tend to be attached via external connectors and cables on the outside of the access point. If you've got access to the slide deck, it'd be worth having a look at slide number 16 now, where we've got a few images which relate to our next topic, which is omnidirectional antennas. On there we've got a picture of an omnidirectional antenna. It's a dipole type antenna. If you can't see them, a good mental picture of what it looks like is the short stubby antennas that you tend to get attached to walkie-talkies. It's a short antenna that's usually a few inches long, and we've drawn a radiation pattern on there to represent the way that RF actually radiates out in all directions from the dipole antenna. And another good mental picture to sort of visualize the way that RF is propagated from an omnidirectional antenna is again to think of our light bulb analogy, where we've got light radiating in all directions fairly equally around a room. Or another good analogy is to think of a pebble being dropped into a pond. If you imagine dropping a pebble into a pond and you get the ripples going in all directions at once, that's a very good visual analogy to consider. So that's what we mean when we're talking about the omnidirectional radiation pattern of an antenna. And if you move across to slide number 17, I've actually posted a picture there of an access point with the cover removed, and you can actually see what the onboard omnidirectional antennas look like. They're just small components which are mounted directly onto the chassis of the wireless access point. Quite an interesting picture there. And moving on to slide number 18, we're talking a little bit more about directional antennas. And whereas omnidirectional antennas radiate their RF energy in all directions at the same time, with a directional antenna we alter the characteristics of the antenna so that it actually tends to focus its RF energy in one direction. A good analogy when thinking of directional antennas is to think of a torch. With the torch we've got the reflector assembly, and we've got the light bulb in the middle of the reflector, and because of the reflector behind the bulb we actually get the light beam travelling in one particular direction. And it's a very similar concept with antennas. We tend to put some sort of reflector behind the main radiator to give the antenna a directional characteristic. One particular directional antenna you may be very familiar with is something like a satellite dish. That's a very good example of a directional antenna that's got a very tight beam width that focuses RF energy in a very narrow beam width. We don't tend to use the parabolic type antennas that you use in satellite systems, but we do have antennas such as patch antennas and sector antennas that we try to focus the RF energy in one particular direction to provide coverage in a focused area. Well, we've probably covered quite enough for this particular episode. We'll be carrying on looking at more characteristics of wireless access points in the next episode. I'd like to encourage you to get along to the website, which is wififorbeginners.com, where you can check out the slide deck that accompanies this and all of the other episodes. You can also find the accompanying audio files, and you can access quizzes and other resources which are provided at the site to help you with your studies. So thanks very much for joining me on this particular episode. I look forward to joining you again soon on the next episode of the Wi-Fi for Beginners podcast.